Hello, today we are having a full simulation of an engine. In this case, we're going to have four-cylinder engine simulation. Very important part here is that it can be applied or it can be used on 6, 8 or the quantity of cylinders you want to have. The method is just the same. And also you can use the sequences of explosion of the cylinders according to the file I'm going to be including on this video. Okay, the components that you see here on the screen, we have 9 components, including skeleton, valves, and everything. You're going to have them into Blackboard, so you can use them to simulate. Okay, I'm going to use NX. Open, and then if you have all the components in the same folder, you can only double click on full engine assembly and you can have everything. Okay, you don't have to work, or specifically on this exam you don't have to work on the assembly. Okay, well, let's go to motion simulation. And we're going to create a new case of simulation. I have another motion here, so let's start with new simulation. In this case, it's going to be CO2 motion underscore CO2, and this is the case because I have a CO1, a previous one. Okay. Remember, very important, to cancel the motion joint wizard. Okay, we don't need it, and we have all the components here. Let me tell you, in the ignition sequences you can see how the internal combustion engine works, and you can see here on this part that for the case of the four-cylinder engines, and in the case of inline motors or engines, we can have the sequence 1, 3, 4, 2 or 1, 2, 4, 3. I'm choosing 1, 3, 4, 2. So in the Excel file I'm including here in the Excel valve paths. I'll give you a second. Let me open. Okay, you can see that there are the four cylinders for the intake valves and for the exhaust valves. And some of you asked me how to simulate the motion of the valves. Well, I used, see, when it is on 360 degrees, I used to increase and decrease the motion of the paths using the equations of the CAM simulation. For 5 millimeters, beta as 90 degrees, and C5 and C6 as the equations for the motion. Okay, you don't have to create these quantities, the simulation of the CAM. You already were evaluated on CAM simulation in the second part of the exam. So in this case, I need you to work on the simulation of the engine. Okay, so let's work on this. Remember, let's go to show and hide solid bodies, and let's start working on the links. The first link is the crankshaft, the most important one in this simulation. Include all of the 4 circles. Okay, you see here, center of mass is the first one, center of inertia the same. Remember, 1 kilogram, 2, 2, and 2 for the parallel inertia moments, and 1, 1, 1 for the orthogonal inertia moments. CO1, CS from crankshaft. Apply. Then let's work with the connecting roads. The first one, we're going to use these 3 circles and the line. Center of mass is the central circle. Center of inertia, that same circle. CO1 underscore connecting road. Apply. The same for the second one. 3 circles and 1 line. Center of mass, the central circle. Center of inertia, the same central circle. CO2 underscore CR for connecting road. Apply. Work with a third one, 3 circles, 1 line. Center of mass, the central circle. Center of inertia, same circle. CO3 underscore connecting road. Apply. Then the last one, 3 circles in the line. Center of mass, center of inertia. CO4 underscore CR. Apply. Let me see. Okay, we have all these 4 connecting roads. Then let's go for pistons. Okay, horizontal, vertical, and the central circle. Center of mass in inertia, that circle. CO1 underscore piston. Apply. Top, line, and circle. Center of mass in inertia. CO2 piston. Apply. Line, vertical, circle. Center of mass in inertia. CO3 piston. Apply. Line, vertical, circle. Center of mass in inertia. CO4 piston. Apply. Then let's go to simulate the valves. To create the links of the valves. First, all the intake valves. Just only line in the circle. Center of mass in inertia. 01 intake valve. Apply. Then let's go with the second one. Center of mass in inertia, the central circle. CO2 underscore IV from intake valve. Apply. Line, circle. Center of mass in inertia. CO3 underscore IV. Line, circle. Center of mass in inertia. And it's 04 IV. Apply. Then let's go with the exhaust valves. 2 entities, line and circle. Center of mass in inertia, which is 01 EV. Apply. Line and circle. Center of mass in inertia. CO2 EV. Apply. Line, circle. Center of mass in inertia, which is CO3 EV. Line, circle. Center of mass in inertia, which is 04 EV. Apply. Okay, and we have all of the links. Don't worry about these horizontal lines. And then let's go with the joints. We're going to have revolutes. The first case, touch the circle, okay, frontal circle, make positive. And this one we're going to have a driver, constant driver of 1 revolute per second. Display scale 3, 01, rev, CS from crankshaft. Apply. And then let's go with sliders. Touch this vertical line. We have this vertical vector on the positive side. It's okay. That's one we need, and that's C1 SLD from slider piston. Apply, touch the line, okay, inside the area of the circle, and that's 02 SLD piston. Apply, and then remember to touch the line inside the area of the circle, okay, preferably in the top part of this zone, so we have the vertical vector on the positive direction. Okay, CO3 underscore SLD piston. Apply, and then touch the line CO4 SLD piston. Apply. Okay, we have pistons now. Let's go with the intake valves. We continue with sliders. Okay, once again, line, we touch the line. Let me do it again. I touch this line. And then let me open joints. Okay, expand joints, Z1 underscore SLD IV. Apply, and on. Touch. See, it is moving to the negative direction, so let's change it to positive. CO2 underscore SLD IV. Apply. Touch the line. To move using the pen, let's click on Shift and click on the scroll. Okay, press the scroll. Okay, move it to the positive direction, and that one will be 03 underscore SLD IV. Apply, Shift and scroll. Okay, positive 04 underscore SLD IV. Apply, and then let's move to exhausts. C1 underscore SLD EV. Apply, touch the line, positive. CO2 underscore SLD EV. Apply, touch the line, positive. CO3 S underscore SLD EV. Apply, and then touch the line, positive. CO4 underscore SLD EV. Apply, and then let's move to the internal revolutes. Those are very, very important. So let's go to revolute, and let's touch, in the first case, the first cylinder, this circle. See, this is the negative direction, so let's change it to positive. And then in base, click on select link, because you see this circle belongs to the connecting rod, and this revolute has to be dependent to the crankshaft. So select link, click the crankshaft, display scale 3 for all the revolutes, and this gets 01 rev crankshaft connecting rod. Apply. Move to the second one. Touch the circle, positive, select link, touch the circle, display scale 3, CO2 underscore RAV CS CR. Apply, touch the circle, positive, 3, CO3 underscore RAV rev CS CR. apply. I forgot select link, so I cancel. Double click on the last one, and then select link, click on the crankshaft. Okay. Let me show you how I found that I forgot the base link or the select link, because this one is dependent and this one has a ground symbol, so it has to be corrected. Double click again, select link, touch CS, and now the ground symbol, the ground icon disappeared. Okay, once again, joint, Revolut, select link, positive, select link, touch the circle, 3, 04 underscore rev, connecting crankshaft and connecting rod. Right. Let's move to the top Revoluts. The first one, touch it, positive, select link, touch the line that belongs to the piston, 3, 01, rev, piston, connecting rod. Apply. Move to the second one, touch the circle, positive, select link, touch the line, display scale 3, CO2 underscore rev, piston, connecting rod, apply. Okay, touch the circle, positive, select link, it's the vertical line, display scale 3, CO3 underscore rev, crankshaft, no, excuse me, piston, connecting rod. Apply. And then let's touch this last one, touch it, positive, select link, touch the line, display scale 3, 04 underscore rev, piston, and crankshaft, no, connecting rod, excuse me. Apply. I think I have all of the joints in all of the links. Okay. Cancel. Then let me work with the valves. Okay. Then let's go to the first intake valve. So go to driver, go to function, function manager, table in AFU, click on new, the record, it's 01 underscore IV, XY data, the increment it's just 1 second over 360, we are having 1 revolution per second, and every point is simulating 1 degree. So if we have 360 degrees every second, so in this increment we have to divide every second in 360 parts, 720 points. Keying, let me delete it, and let's go to intake valves and only the gray area, copy, and then paste, delete the last space. Usually it's not a problem at all, but I used to do it just to avoid any other extra problem. Okay, and just checking here, data it's already there, it's okay. Okay, record name already exists. Let me change maybe to sim maybe from simulation.